All right, we're going to try to prove another identity. Here is the next one. It's got secant of theta minus 1 over tangent of theta is equal to tangent of theta over secant of theta plus 1. Now that looks kind of weird because they're almost the same thing except sort of flipped over or whatever, a little sign change. Here's what we're going to do. We are going to take a look at the more difficult side. Now, good question, which one is? Well, I think this one is, and the reason I'm choosing this is because the denominator is more complicated. So I'm going to multiply the denominator of this one and the numerator by the conjugate. You don't always do that, but it seems like those are the examples that I have. So I'm going to take this and multiply secant theta minus 1. Secant theta minus 1. That gives me tangent theta times secant theta, and we'll deal with that in a minute. So that multiplication, and then this one, minus 1 times tangent theta. So tangent theta. This one gives us secant theta times secant theta, that's secant squared of theta, gives us minus secant theta, and then here we've got plus secant theta, and then here we've got minus 1. Okay, now what do I have? Well, for one thing, I've got secant theta and minus secant theta, so those are gone. The next thing I want to do is I want to deal with these and try to simplify them, because my goal is to try to make this look like this. Well, look at this. It's got a common factor of tangent. So let me factor that out. I guess I should have left it factored out in the first place, huh? Look at that. Should have left it factored out. Oh well. So I'm going to write it factored out. That's kind of a waste of time, but you don't always know what you're getting. So here's the deal. So I took tangent out, I've got secant, got a minus, and tangent out of that, I've got a 1. I mean, it's just back to this problem. Now this thing down here, I've got secant squared of theta minus 1. And what I've got to do is I've got to consider the fact that secant squared of theta minus 1 has a square in it, so it's like a Pythagorean identity. So one of the Pythagorean identities that had secant in it is 1 plus tangent squared of theta equals secant squared of theta. And you could look those up. But if I want to find out what secant squared of theta minus 1 is, I need to like subtract 1 here and subtract 1 here. So here's what I've got. I've got tangent squared of theta is equal to secant squared of theta minus 1. Hey, that's pretty cool because now I could put something really simple in this denominator. So here's what I've got. I've got tangent of theta, this is from here, times secant theta minus 1 over tangent squared of theta. Okay, so I replace secant squared of theta minus 1 with tangent squared of theta. Well, tangent over tangent squared cancels one of the factors of tangent. And I'm left with this. I'm left with secant theta minus 1 over tangent theta. And guess what? Looks just like this. We are done. So we have proved it. Okay? That's it. Thanks.